Hey everyone, welcome to another video in Spark Structure Streaming with Kafka playlist. In this video, we'll be talking about streaming aggregates in Spark, and we'll see what is the difference between tumbling versus sliding window function with Kafka, right? So to understand this, let's think about one use case, right? Suppose you want to build a monitoring real-time sensor data in smart factory, right? So you want to create a monitoring around IoT devices data, right? So the scenario is a small factory uses IoT sensors on in machinery to monitor performance metrics such as temperature, vibration, and energy consumption, right? So the factory needs to aggregate sensor data in fixed intervals to identify anomalies and optimize efficiency. So few of the aggregation that they want to do over the time, over a fixed interval time, maybe like for 30 minutes, for every 30 minutes they want to find out what's the average temperature, what is average vibration, what is average energy consumption, so that they know, okay, this particular device, the average temperature is going above like normal, right? Then there is something wrong to that appliance, right? So, and they want to take action on top of it. So you see, like this type of use cases you can solve with a real-time application using Kafka as well as with Spark Structure Streaming. Okay. So to do this, you want to aggregate the data over the period of time, right? Suppose 30 minutes. So you want to apply the aggregates, but you want to apply the aggregates with a timestamp as well. Okay. So to do that, there are different techniques. Something called as there is first technique is something called as tumbling window aggregation. What it does is, a tumbling window is a fixed size non-overlapping window. It is useful for aggregating data within a time period, such as counting the number of items sold in each hour. Okay, so in this diagram I have a time on the x-axis, right? So you have a tumbling window of 5 minutes. So you have 12 to 12:05, then 12:10, and so on. And you have different windows that is getting created. So it's a fixed window and non-overlapping, right? So one window timestamp is not overlapping with the second window. That's how you create the window function. Now let's see like how to create this as a program. Okay. So this very simple. What I have to do, you have a parse stream that we have, so whichever we have been working on, right? This is the parse stream data frame that we have. You have a timestamp, user ID, item, and quantity. Okay, what I'm going to do is I'm going to group by. How I'm going to group by? First, it takes a window function. Okay, what's the window function on top of it? It's on top of the timestamp that we have, right? What's the interval for that? It is 20 seconds. For our use case, let's consider 20 seconds. And what's the second column? Second column is you want to group by item, right? So that's what you give as the second argument. Then we are calculating how many count, and we are just renaming that particular count as item count, right? And this is just to show like what's the start of the window and what's the end of the window. And I'm just printing the item and the item count. Then I'm just writing that as console, right? So let's run this. So I'm just seeing that log here. So if you see that this is the batch number 114. So you have a start and end timestamp, you have the item, and you have the item count, right? So if you see the difference between these two, this is like 12:51:00, 12:51:20, right? So it's like 20 seconds interval between these two. So on this particular timestamp batch, or you can say like window, your item count is 12, right? So this is how you calculate the tumbling window aggregation. There is one more window technique that is called a sliding window. What it does is it aggregates data over a moving time window. For example, you can calculate the sum of quantity of items sold in the past 15 minutes, but the window slides as time progresses, right? So this takes like two parameters. One is like what's the width of that particular window and how much it should slide. Okay. What does this mean is, suppose one of my windows starts from 12 to 12:10 because I have a 10-minute window, and my slide window slide time is 5 minutes. So what happens is, the second window, it will start for 5 minutes later, right? Like 12, it starts from 12:05. That means there is a difference of 5 minutes from the starting of this timestamp to this. Similarly for this, right? So if you see, window 3 starts after, like, once window 2 starts, it starts just after like 5 minutes from that. So this is how the overlapping happens. There might be some scenarios that where you want to use this particular window function, right? So it's the same syntax, only the difference is you add a third timestamp, that is this slide 5 minutes or like 10 seconds or whatever it is, right? Everything else remains the same, only whatever you see in case of tumbling window, you get locked like this, but in sliding window you get like 5 minutes, like whatever slide interval that you are giving, you will see the difference between those start timestamp between two batch, right? So I think this is all I wanted to share, and this is a very important concept. There are a lot of use cases where you can have this like streaming aggregation, and this is a very important concept for you to understand it. So what I'll recommend is, I have given the Kafka producer code. So you produce some code, write some other aggregation, try to filter out the data so that you understand how this is working, right? Work with different output mode, and let me know in the comment section then how you're liking this particular video and the playlist as well. And if you haven't subscribed to my channel yet, please do subscribe. That really motivates me to put some more videos around it. So I hope that you like this video, and I'll meet you in the next one. Bye bye.